Hi, everyone. My name is Diogo. I'm a senior software engineer at Thread Styling. And today I'm here to talk to you about something I really like, which are generators. Does everyone know what a generator is? OK, that's fine. So I'm going to give a quick recap about these generators and iterators and iterables and all these things. So an iterator, basically, is something that you can iterate over, is an object that you can iterate over. And this feature landed on JavaScript a few years ago, I think 2 or 3 years ago. And you can either define an iteration protocol for your objects, you can tell it how it needs to iterate, or there are some newer data structures like maps or sets or generators that implement iterator behavior. This means that you can put a for loop in these objects and it will just loop over them. So a generator, basically a generator is a function that does something that functions don't do, which is to return multiple values on demand. A function can only return one value, a normal function, which can be at different types, but is just one value, while generators can yield up to n values, really, up to infinite values. And there is this property that all generators are iterable by default. So let's just look at some code. This is a code for a simple generator. So this is a generator function. The property of this function is that when you invoke it, this function won't run. This function will, in reality, just create an object, which is the generator object. This is the interface that if you use TypeScript, because I like Ryan, I also like to use TypeScript because it's cool. And this is what's going to return. So today I'm going to base my talk in 2 things, which are the next and the iterator. So let's look at this function. When we are in the call stack executing the first argument, does anyone know what this will return?
0.
So it returns 0 in the value property and done as false. Next statement, more or less the same thing. It goes there, value 1, done false. Next statement, value 2, done false. And for the last statement, it's going to tell us that the value is 3 and that it is done. When you iterate over, although you don't get this done, you only get the value directly. So when you do this asynchronously, this I think landed 1 year ago. I'm not sure, but to be honest, I used this in Node 8 just by using TypeScript and polyfilling everything. So this is the same, but instead of returning a value, this returns a promise of a value. So it's exactly the same code. And doing it in a for loop and yielding in a for loop is the exact same thing as we were doing before. Just now this is asynchronous, and you call it with the nice await keywords. And now you look at this and you say, yeah, I'm not impressed. What is this good for? Because that's what most people think, and that's what I thought when I look into this. I thought, oh, this is just one more shiny object that we are adding to JavaScript that no one will actually use. So let's get to some practical examples. So let's talk a little bit about streams. If you ask me what a stream is, or almost anyone, streams are really wild and no one really knows what they are, except for a few selected individuals. But they are just a collection of data as strings and as numbers. And the only difference is that they don't need memory allocation when they are running, and they are not always available. So this makes them a really, really good fit for asynchronous generators. And I think that the future of streams in Node.js will come through async generators because they are so much easier to reason about and to write code with. So let's get a quick example. I added links to Code Sandbox if you want to play around with it. For most of the examples, you can do it later. So in this example, we can just create a simple wrapper around the stream. So this generator function receives a stream, loops to the stream while it has data. And then in the finally, because we are professionals, it releases the lock. So what is this good for? Let's give a practical example. So in this example, we are performing it's not a full text search, it's just a word search on a document. There is a request and on demand. What this means is that if this document has 4 gigs, I'm going to download it over fetch. Oh, by the way, sorry. Fetch response. The body is a readable stream, is a stream that you can read from. So in this example, we just do a fetch to a file on the internet somewhere that can be many megs long. We iterate over the stream until we find a word. This is a little bit more detailed in the example, like with a proper implementation that searches on the bytes and matches it against words. But what this means is that you, without downloading the full file, without reading it and putting it on your computer, you can just loop over it, and if you find it in the first chunk of the stream, it's going to return straight away, and you know if you have a word in the document. I think this is cool. And I heard that this might actually come as a spec to JavaScript, that you can read these streams with an async iterator by default without doing this wrapping. So another thing is load on demand is also cool. You can start downloading a file. You can show it to the user straight away and then just write the rest while it's coming. Yeah, I think this is a cool use case. You can do it on click. You can do it however you want, really. And the interface is actually much nicer, in my opinion, because you either loop over it or you do an await fetch next. You don't need to worry about knowing the exacts of streams. So another, and this is one of my favorite examples, is to crawl external APIs. We did this a little bit at work, and this example is something that is very usual for us to do in our day-to-day lives. This is an example that fetches the entire commit history of a repo from GitHub, and this yields commits one by one. So what this means is that the consumer wouldn't care about how GitHub does pagination. Anytime he calls await, he will get the next commit. You could integrate this however you wanted. So for example, you could basically put the commits in a database that you own one by one without putting a range and destroying it. And this would all work for free. The way you would use this API would be you create a generator. You say, for example, that you want to fetch all commits from node.js. And you could just do a for loop, and it would loop through all the commits that have ever been in that repository. In the for loop, you could do whatever you wanted. Or you could just get them on demand. Basically, if you wanted to build a client for GitHub that showed commits on demand, this could be a way. Just before this, we actually ran one of these in production when we were migrating 100,000 items from Elasticsearch to our database. We ran it with a generator where we paginated over the collection on Elasticsearch. We ran it against it like 7 times maybe, counting all the different environments. It never failed, and we have all the data that we needed in our database without destroying it, doing 1,000, or without writing a massive piece of code just to handle this migration. So another cool one that I really like is who has implemented infinite loaders here in React or Vue or whatever. It's a mess, right? It's like when you start to scroll down, if you don't pay attention to things like, did my search parameters change? Do the requests arrive in the right order? Because we don't have any guarantees that the requests arrive in the right order. I found that we had a few implementations of infinite loaders. They were pretty much all broken, to be honest. We re-implemented them with async generators. We never had happier times. So this could be a way you basically create a signal, because we are professionals. We want to cancel the requests. When someone, for example, changes the search parameters, you want to cancel the request because you don't want to set state to something that is no longer there. And you can basically just, if you use cursor pagination, you can loop while the cursor is there. Then you can basically request it on demand, as, for example, your component asks for more data. You just click await next, then set the state. If your search parameters change, for example, you just call abort to make sure that you don't have any race conditions, and you just recreate the generator with a loader, your API loader, and the search parameters. And that's it, really. A few examples. I hope you guys use it in production tomorrow.